Determination of the amount of sodium carbonate and sodium hydroxide in a mixture by titration.
The aim of the experiment is to determine the amount of sodium carbonate and sodium hydroxide in a mixture using hydrochloric acid. The chemicals required are sodium carbonate, sodium hydroxide, hydrochloric acid, phenolphthalein, methyl orange, and distilled water.
Principle. The titration of a mixture of NaOH and Na2CO3 with standardized HCl solution has two equivalence points. The first equivalence point is due to the conversion of all the carbonate to bicarbonate and sodium hydroxide to sodium chloride as follows. Na2CO3 plus HCl gives NaHCO3 plus NaCl. NaOH plus HCl gives NaCl plus H2O. The pH of the rising solution is around, therefore, phenolphthalein could be used as an indicator. The second equivalence point is due to the reaction of the resulting bicarbonate with an excess of HCl solution as follows. NaHCO3 plus HCl gives NaCl plus CO2 plus H2O. In this stage, methyl orange is used to find the equivalence point because the pH of the solution at this point will be around 3.8.
Titration 1. Standardization of HCl. Pipette out 20 ml of standard sodium bicarbonate solution in a 250 ml clean conical flask. You can repeat this twice if you have a 10 ml pipette. Add 2-3 drops of methyl orange indicator. The solution will turn yellow in color. Titrate the mixture against hydrochloric acid taken in a burette. Stop the titration when the solution turns lightly pink to orange in color. The end point is the color change from yellow to orange. Repeat this titration for the concordant values.
Calculation for titration 1. Standardization of HCl. Volume of HCl V2 equals 19.2. Normality of HCl N2 unknown. Volume of N2CO3 V1 equals 20 ml. Normality of Na2CO3 N1 equals 0.05 N. Formula for finding normality of HCl. V1 N1 equals V2 N2. N2 equals V1 into N1 by V2. Putting all the given values in the formula gives us 0.052 N.
Titration 2. Estimation of the mixture of sodium carbonate and sodium hydroxide. Make up the given solution in a 100 ml standard measuring flask. Pipette out 20 ml of the made up solution in a 250 ml conical flask. Add 2 to 3 drops of phenolphthalein indicator. The solution is titrated against standard hydrochloric acid in a burette. The end point is the color change from pink to colorless. Titer values noted as AML. To the same conical flask solution, 2 to 3 drops of methyl orange indicator was added, that is without pouring out the conical flask solution. Now the solution will turn yellow. This is titrated against standard hydrochloric acid from A milliliters till B milliliters is reached. That is till endpoint orange color is reached. The titration is repeated for the concordant values.
Calculation for titration 2. Here we are to estimate the amount of Na2CO3 present in the mixture of given solution. The requirements include volume of HCl, normality of HCl, volume of mixture, and normality of the given mixture. Here we take HCl because it is the burette solution. The volume of HCl is found out to be 2C, where C represents the volume of acid used for half carbonate ion neutralization. And normality of HCl, we obtain it from the titration 1. Volume of the given mixture remains constant to be 20 ml because this is the solution which we pipetted out. With the formula V1N1 equal to V2N2, we could finally obtain the value for normality of the given mixture, which is depicted as N2. Finally, we are to find the amount of Na2CO3 present in the entire of the given solution, which is given by another formula, namely normality of Na2CO3 into equivalent weight of Na2CO3 divided by 10, which is N2 into 53 by 10, which gives the final amount of Na2CO3 present in the given sample of mixture. Estimation of NaOH. Here, we are to find the amount of NaOH present in the whole of a given solution. The requirements for this particular estimation includes volume of HCl, normality of HCl, volume of the given mixture and normality of the given mixture. Here, we are considering HCl because it is a Buret solution. In order to find the volume of HCl, we are using a formula which is A minus C. Here, A represents the phenolphthalein endpoint and C represents the volume of acid used for half a carbonate ion neutralization. The normality of HCl is found out from the titration 1. And the volume of mixture, the given mixture, is what we pipetted out about 20 ml. Then, using the formula V1N1 equal to V2N2, we will finally find the normality of the given mixture. Now, there comes another formula which actually helps in finding out the amount of NaOH present in the whole of a given solution, which is normality of NaOH into equivalent weight of NaOH divided by 10. That is N2 into 40 by 10, where N2 represents the normality of NaOH which we found out earlier.